All right, let's talk about Iceland. We're going to dig into the really fascinating story of how this one country's unique geology, I mean, literally the fire and ice under its feet, has powered its entire economy, from old school heavy industry all the way to the heart of our modern digital age.
So let's just start with a number, and it's a wild one. 55,000 kilowatt hours. Now, what is that? That's the amount of electricity Iceland generates for every single man, woman, and child in the country every single year. And to be clear, that number is absolutely insane. Just to give you an idea of how massive that really is, take a look at this. Iceland produces over 4 times more electricity per person than the United States, and it's nearly 8 times more than an industrial powerhouse like Germany. It's not even in the same league. It's on a completely different planet. So that kind of begs the big question, right? How on earth does a remote island nation with such a tiny population become one of the world's biggest energy producers? Well, the answer is buried just beneath the surface. You see, the secret isn't industrial might, not in the way we usually think about it. It's the fact that Iceland is sitting on top of a massive volcanic powerhouse, and they figured out exactly how to plug right into it. The magic formula really just comes down to 2 incredible natural forces working together. On one hand, Iceland is the land of volcanoes, which means immense heat. On the other, it's the land of glaciers, which means immense water. And when you put that heat and that water together, you get a ton of energy. And that gets us to the core concept here, geothermal energy. All it really means is harvesting the planet's own internal heat, which in Iceland's case is supercharged by all those volcanoes, to generate a constant, clean, and incredibly powerful source of electricity. And the process itself is brilliantly simple when you think about it. First, they pump cold water deep down toward all that volcanic heat. That heat, of course, turns the water into high-pressure steam. Then, that steam rushes back up to the surface, spins some turbines, and boom, you've got electricity. It's like a giant natural kettle powering the whole country. So, the most important part of this whole thing is what it creates. A massive, seemingly endless surplus of electricity that's both 100% renewable and incredibly cheap. And when you have that much cheap energy just lying around, it becomes your single greatest economic export, even if you don't actually ship it anywhere. All this extra energy basically became a giant magnet. Back in the 20th century, it attracted one industry that craves cheap power more than any other, turning that free energy into what you might call cold, hard cash. Yeah, there's a saying in the industry that aluminum is essentially solid electricity. Why? Because the process of smelting it, turning the raw ore into shiny metal, is one of the most electricity-intensive industrial processes on the entire planet. It just devours staggering amounts of power. So put yourself in the shoes of an aluminum company. Where do you want to build your new factory? In a country with high, unpredictable energy prices, or on a volcanic island where electricity is dirt cheap and the price literally never changes? It's a no-brainer. And that's exactly why Iceland became a global hub for making aluminum. Okay, but times change, right? And today, the world's thirst for cheap, abundant energy has a totally new face. We've moved on from turning energy into cold cash, and now we're turning it into what some people are calling the new digital gold. The new aluminum smelters of our time are data centers, the backbone of the internet, AI and cloud computing, and of course, cryptocurrency mining operations. And both of these industries share that one critical trait with aluminum: they consume colossal amounts of electricity.
I mean, the parallel here is just crystal clear. The fundamental need is identical: massive, cheap electricity. The only thing that's really changed is the output. You're going from a physical metal to digital information. Iceland's core economic advantage simply rolled over from one century right into the next.
And for data centers, Iceland is just a perfect storm of benefits. Rock bottom energy prices, that's number one for sure, but it's also a 100% renewable grid, which is a huge deal for companies that care about sustainability. The cold climate also provides natural cooling for the servers, which cuts costs even more. And to top it all off, it's a politically stable and secure location. It's the whole package. And the impact of this is just stunning. Check this out. A full 90% of all electricity consumed in Iceland is devoured by just these 2 types of industries: the old guard of aluminum and the new guard of data and crypto. The entire public, all the people, all the other businesses, they run on just that tiny 10% slice. It's wild. So let's zoom out and just look at the big picture here. This whole story is a straight line that flows directly from the geology of a country to the global digital economy. This is the entire Icelandic model in a nutshell. It all starts with a volcanic geology. That's the source. That creates the core asset, which is a surplus of cheap energy. That asset first attracted Industry 1.0, aluminum, and now it's attracting Industry 2.0, the data economy. It's a direct, unbroken chain reaction. And here's the single most important takeaway from all of this. Unlike most developed nations, Iceland's modern, high-tech economy isn't primarily built on finance or services or manufacturing. It is built, quite literally, on the bedrock of the country itself. Its geology is its economy. And that leaves us with one final, pretty cool thought to chew on. We often hear that data is the new oil, right? It's the most valuable resource of our time. Well, if that's true, then maybe in places like Iceland, the volcanic rock right beneath their feet has become the new oil rig, pumping out the raw energy that fuels our entire digital world.